Hello, everyone, and thank you for attending this afternoon's session on advancements in high voltage cable design for EV systems. We're breaking this up into three distinct sections, and I'll cover the first part, which will be on material science and irradiation cross-linking technology. And then Rick Anick will take the middle portion and speak specifically to high voltage cable design considerations for EV, HEV systems. And then to wrap things up will be Matt Hornick, who will speak to market support of EV products. A little bit about Champlain Cable. We were founded over 65 years ago in 1955 in Winooski, Vermont. And at that time, we were making primarily aerospace wire, thin light frame, airframe wire. And in 1972, we started custom polyolefin material development and installed our first three irradiation units. So let's fast forward to our automotive exposure. We entered the automotive market over 28 years ago in 1992 with cross-linked polyolefin battery cables and also high flex door wires for sliding door systems. We entered the electric vehicle market in 1998 with a high voltage battery cable on the EV1 platform. And in the early 2000s, we started to see fairly rapid market acceptance of Champlain's irradiated cross-linked polyolefins. And over the course of the next several years, Champlain expanded by opening 2 facilities in El Paso, Texas, and installing 5 additional irradiation units and adding conductor drawing as well. So let's touch on material science. Today's polymer technology is far more advanced than in years past. And those advancements include the chemistry of the materials themselves and also the analytical tools available to research, blend, and create new materials. Now, you might be thinking, why is a wire and cable manufacturer talking about material science? And it's interesting. That is the core of what we do. We create and blend our own XLPO materials to meet a customer or a market need. And it's kind of funny, actually. A lot of our customers, tiers and OEMs alike, have referred to us from time to time as more of a chemistry material company who just happens to put their materials on wire and cable. And we like that descriptor, and we find it to be a real compliment. So the first advancement we'll talk to today is that of flexural modulus. This is a measure of a material's resistance to bending when force is applied. So if you think of all the plastics that might be in a vehicle, an electric vehicle, some are very hard and stiff, like a nylon 6/6, which might be used as an overmolding to a sensor. Very stiff, hard material would have a very high flex mod. And compare that with a very flexible battery cable that would have a much lower flexural modulus value. And cutting edge advancements in lowering flexural modulus properties of polymers allow for today's XLPO materials to be more flexible than ever before. And this is a real key feature, because if you look at the image on the right, the orange, these are Champlain X-Rad high voltage battery cables in an EV system. And this is very common. It's a very tight space. It requires a flexible cable with a tight bend radius, so cables can be routed and terminated effectively. The next advancement we'd speak to is rheology. Now, rheology is the study of material flow under applied stress. So for us, this is an advancement in extrusion. So the polymer itself is in a pelletized form, and then it is put into the extruder and moves to a melt form where it is applied to the conductor. So we can't simply throw it in the extruder and turn the heat up and start extruding it on the cable. It's a very controlled and purposeful process, moving the material from a pellet stage to a melt stage. And rheology optimization allows for improvements in the extrusion process, which results in the final product having tighter diameter tolerances and a smoother surface, both which affect connector sealing. The next advancement we would speak to would be that of blending facilitators. These facilitators improve dispersion and homogenization of ingredients, resulting in a more consistent polymer. So in a polymer that you develop with all the ingredients that are involved, it is possible to have areas of that material with higher concentrations of a specific ingredient and lower concentrations of a specific ingredient, and that's not really optimal. So the facilitators allow us to have a better overall and consistent cable performance because all of the components within that material are equally dispersed among the material itself. And this can affect properties and improve properties such as flame resistance and thermal stability. The next advancement we would speak to would be the use of compatibilizers. Compatibilizers allow the mixing of polymers with different properties to take advantage of each polymer's strength. So when you look at a recipe or a formulation for a particular cross-linked polyolefin that Champlain might develop, there's different ingredients and resins that may or may not want to neatly blend together. Maybe they're an organic versus inorganic type material. And what a compatibilizer does, it is allows these materials to shake hands, so to speak, and work in a way that creates enhanced performance of the material. So one way we like to think about it is that compatibilizers help to create a super blend of polymer with properties that one polymer alone cannot perform. And then, of course, there are always new polymer technologies coming into fore. So our raw material suppliers are constantly improving polymers, which can improve cable performance in areas such as flexibility, oil resistance, volume resistivity, and other properties such as thermal robustness, pinch, crush, etc. So our takeaway on the material science portion would be advances in polymer science have been a real catalyst for the development of some of the highest performing XLPOs to date. So now we'll move into cross-linking technology and specifically irradiation cross-linking technology, which is Champlain's preferred method. But let's define cross-linking first. Cross-linking is the process of permanently linking polymer chains together with carbon-to-carbon bonds. And the polymer then changes from a thermoplastic, which would melt under excessive heat, to a thermoset, which will not melt under excessive heat. And when you do this process and get these carbon-to-carbon bonds, many other performance properties are enhanced, such as oil and fluid resistance, heat resistance, abrasion performance, compressive force resistance, pinch, crush, and so on. So let's look at the diagram on the right. There are two polymer chains. The chain on the left is an uncross-linked chain. The polymer is randomly intermeshed, and if excessive heat is applied, it will melt. After cross-linking, you get the polymer chain on the right, where the hydrogen atoms that were attached to some of the carbons have been removed from the carbon, and that causes the carbon to attach to another carbon. And when it does so, it will never again release. It is cross-linked, and you can see it's a much neater arrangement of the polymer on the right, and you can see the carbon-to-carbon bonds. So most cables that you probably work with are either cross-linked or at least a thermoset. Silicone, for example, is not cross-linked, but it is a thermoset. And polyolefins are cross-linked to become thermosets. So our method of doing this is irradiation. And this method of cross-linking utilizes a stream of high-energy electrons to create these carbon-to-carbon bonds, which link the polymer chains together. And irradiation is a very controlled process and allows the highest performance possible. And this is a real important point. With irradiation, we control the amount of irradiation. We control the dosage for each particular material that we have. And that's kind of a big deal because not every material wants the exact same dosage of cross-linking. You can think about it on a spectrum. A little higher cross-linking may not optimize that material, and a too low of a degree of cross-linking will not optimize that material. But you find the perfect amount of cross-linking for that material to optimize the performance of that material and make it the best that it can be. And the image on the right is cable underneath an irradiation unit. You can see it is set up in a figure-8 configuration, and it runs around and around and gets bombarded by high-energy electrons during the process, and that causes the hydrogens to break away from the carbon and causes the carbon to attach to another carbon and for the cross-linked final product. Now, of course, in wire and cable, there are other cross-linking methods, such as chemical or silane moisture cure cross-linking. Those methods are not as well controlled, and they also have polymer limitations and thermal limitations compared with irradiation cross-linking methods. So irradiation cross-linking allows cost-effective modification of a wide array of polymers to significantly improve their performance. So we're not just working with polyethylenes. We can work with EVAs and low linear density polyethylenes and high density polyethylenes. There's a number of materials that we think of it as a palette, like an artist's palette of materials that we can choose from to create our material and optimize its performance. And this allows our high voltage cables to be used in harsh environments such as temperature extremes, fluid exposure, mechanical stress, and other challenging conditions. Then on top of that, you add advanced polymer formulation, like we had on the material science slides, and that can yield products with additional features such as improved flexibility, higher voltage withstand, which allows thinner walls and therefore smaller diameters. You can formulate products with a longer thermal life and a resistance to spikes in temperature as well. So, you know, power cable designs in EV systems are typically specified to a worst case design scenario. So just take a city bus, for example. Its average scenario is going to be driving its city route day in and day out. But there will be differences. You might have a full bus, fully loaded with luggage and passengers, and maybe this is a bus which is going to travel up a mountain pass because it's a tour bus, and that is going to draw a lot more current than a steady state standard route that is being planned around. So longer life and exposure to excessive heat through current is another design consideration that irradiation cross-linking products can allow you to design around. And there's also processing advantages, and this shouldn't be dismissed. It's the processing of the cables is very important to the tiers. You know, they are cutting and stripping cables hundreds of times an hour, sometimes thousands of times an hour. And the cables need to cut and strip cleanly. And irradiated XLPOs generally do that quite well. And some chemical cross-linking methods do not do that as well. So the takeaway from the irradiation portion, I think, would be that irradiated XPOs are becoming the high voltage material of choice by many tiers and OEMs. So now I'll pass the baton on to Rick Yannick, who will discuss specific cable design considerations for EV HEV systems. Thank you.
Thank you, Dave. Hi, everybody. I'm Rick Yannick. I want to talk about key performance considerations of the cables. The first key performance consideration has to do with the connector and the cable interface, which is extremely important for the safe operation of a vehicle. Compression set is the tendency of a cable's insulation to permanently deform due to pressure at elevated temperatures. You can see here in the illustration on the right, this was a cable that had undergone temperature cycling, and you can see the deformation of the insulation. That deformation can cause a failure at a connector seal, allowing for the ingress of water, which can cause electrical failure. The resistance of this deformation is key to cable attribute for proper long-term connector sealing and performance. Now, let it be known that not all XLPOs are created equal. Some have much more poor compression set properties than other XLPO insulations that have much better compression set properties. And what I mean by better compression set properties means less deformation. Connector suppliers are also modifying their connectors to better manage deformation. And what they're doing with their seal glands is using lower durometer materials, which will not deform the XLPO insulations as much. Compression set and original diameter retention are really opposites of one another. The compression set is how much the deformation remains permanent versus original diameter retention, which is a measurement that is used by our ISO standards 19642-9, which outlines a minimum diameter retention of 40%. Now, what some of our connector manufacturers have discovered is that number is not good enough, so some OEMs have established their own more stringent requirements in order to ensure the integrity of the cable connector interface. 80% is an example of a typical OEM requirement. This requirement is optional per the ISO 19642 standard, but it's typically considered an industry best practice. And I should mention that the ISO 19642-5 does not have this, but really it should, because there are connector interfaces on unshielded high voltage cables as well. And you can see the last column on the right, the X-Rad ErgoFlex, the typical value of that is in the low 90%. Now, a key takeaway to this is diameter retention is a key consideration when selecting high voltage power cables. Thermal robustness is also very important. HEV engine compartments typically have high nominal temperatures, and the components must perform for thousands of hours. And typically when you think about an EV, you don't think there might be high temperature, but in fact there is. And there's little airflow. So even in EV systems with no internal combustion engine, high current will heat up the cables due to temperature rise. Now, this is an important feature that many EV manufacturers have taken advantage of with high current insulation and high voltage cables. If an insulation can withstand a higher temperature, they can pump more current through, raising the temperature of the conductor, but not damaging the insulation. And this will result in using smaller size conductors, reducing weight, lowering cost, and making it easier to install the cables. Thermal performance is even more critical when both environmental temperatures and current are affecting the cable, and when the cables are right at close proximity with limited airflow. And that's a key point there. Limited airflow is very important to understand. We can do a lot of modeling which assumes no airflow, but if there is good airflow, that environment may be a little bit more forgiving. High voltage cables must be designed to withstand elevated temperatures for extended periods of time. ISO 19642 cable standards define short and long-term aging requirements. The long-term aging requirements are 3,000 hours at the rated temperature, and the short term is 240 hours at a temperature that's 25 degrees C higher than the rated temperature. You can see the pictures on the right. We have a rubber cable that was rated at 150 C, but did testing on it for 3,000 hours, and you can see the cracks in the cable, which form a very dangerous situation. As you can see, the XLPO cable on the right aged very well, unlike myself. Cables should withstand thermal excursions beyond the rated temperature to ensure they don't fail before the circuit breakers and fuses can activate. This is something some people are not aware of, is that fuses that are rated at 150 amps, let's say, for example, will take much higher amperage than that for a period of time before they go, and before they blow, I should say. And the high voltage cable must be able to withstand those temperature excursions. So it's not unusual to require a cable to be able to withstand temperatures of 25, 50 degrees above its rated temperature, which is good for the XLPOs because they don't melt. A good takeaway for this is the thermal requirements of an EV or HEV cable systems requires careful review. Mechanical strength. Mechanical strength such as abrasion, pinch resistance, determines the life of a cable when in contact with these forces. Cables with poor abrasion resistance are susceptible to potential failures. And in this case, I'm thinking about maybe in vibration where you have conductor to conductor or cable to cable rubbing. Thin spots in the insulation are at risk of a high voltage breach. So as you rub away the insulation, it becomes more susceptible to voltage breakdown. Excessive forces can cause exposed conductor and risk electrical failure. And best case I can think of in this situation is when a vehicle is serviced and tools are getting close to some of the cables and might cause pinching and other things like that. ISO 19642-5 requires abrasion tests for 6 millimeters squared and smaller. Larger sizes are at the customer discretion. Now, I should mention that most of the available conventional test equipment for abrasion, sandpaper abrasion and scrape abrasion are a little bit cumbersome when it comes to testing larger sizes like 35 and 50 millimeters squared. High-performing thin-wall XLPO cables often perform better than thick-wall rubber, saving space, weight, and cost. The next two slides are pretty interesting. We did an abrasion test on a rubber thick wall cable and on an XLPO X-Rad thin wall cable. Now, most people would think that the thick wall would give you added insurance for safety, but actually the contrary is true. In this test that we did, which was a sandpaper abrasion, you measure the length of sandpaper before you reach the conductor. And the length of sandpaper on the rubber thick wall was 695 millimeter. Now on the thin wall, it was 1,478, more than double the abrasion resistance of the thick wall cable. Pinch 2 is another parameter that we do testing on. And you can see here again, we tested a X-Rad thin wall compared to a rubber thick wall. Now in this case, with the rubber thick wall, it was able to withstand 80 pounds of force before breaking through to the conductor. Unfortunately with ours, our equipment only reached 95 pounds, so we recorded 95 pounds on the thin wall, and that maxed out our equipment, so we're not sure exactly how much more pressure it would take before failure. Important takeaway on this is high voltage cables must be tough enough to withstand vibration and accidental stresses. Fluid and chemical resistance. Automotive fluids can have a degenerative effect on cable insulations. The insulation can absorb and react to the fluid, causing a split in the insulation and result in an electrical short. Now, in this case, when the insulation absorbs, say, like an oil, and becomes really thick, it becomes softer and becomes much less tough. So its tensile strength is often cut in half or even cut down to 25%. And that can result in disastrous situations where the insulation might even split on itself or be split easily when moved around. Fluid resistance at elevated temperature is much more difficult than ambient temperatures, and it should be noted that for every 10 degrees you go up, the result of the swell or weakness of the insulation is going to double. So If you had something that was swelling at 50 degrees, it might be swelling 10%. If you were to test it at 60 degrees, it's very likely it would swell to 20%. And take a look at the picture on the right. Again, we have a rubber type cable, and that's swelled 95%. Now the requirement for ISO 6722-1 is 15%, so much greater swell than what normally would be allowed. And at the bottom cable is an X-rated XLPO with only 9% swell, well within the requirements of the ISO standard. So when you think about an EV, even without an engine, there are fluids that you have to be considered that are in there that can really wreak havoc on cable insulation. There's brake fluid, power fluid, steering fluid, transmission fluid, washer fluid, and other lubricants. Now, in our standards today, there are two really different methods of testing. In ISO 19642, there's a 10-second exposure where you dip the cable into a fluid, and then you do a 240-hour bake cycle at the rated temperature for a total of 4 times to give you a total of 1,000 hours of testing. Now, what I like about this test is it really is a good test for exposure to fluids like battery acid. Normally, when you do like a swell test, which I'll talk about in a second, if you put any insulation into the battery acid, it's not going to react to it for a short period of time. But if you put battery acid onto a cable and then heat it, that rate of reaction goes way up. And oftentimes weaker insulations like rubbers will deteriorate and actually expose the conductor. Very dangerous situation. Now, in the past, ISO 6722 used immersion test, as does SAE standards. And I like these tests because it really simulates what happens when you have a drip of oil on the cable. Unlike the 10-second dip and then bake, that's really not showing a real life situation where you have a constant drip of oil. And that's what the ISO 6722 test does. It's a 20-hour immersion test followed by a winding and voltage test where you measure percent swell. And again, where I talked about percent swell, if you really get a large amount of swelling in the cable, you really have a potential danger for exposing the conductors. Major takeaway from this is potential fluid exposure is important in high voltage cable systems as a design consideration. Now, I'll talk a little bit about the standards, ISO 19642-5 and -9. Both of those are the high voltage versions for copper wire. The -5 is for a high voltage lead wire, and the -9 is for a shielded lead or multi-core cables with either shields or not having shields. These cable standards for vehicles have advanced significantly over the past 20 years. ISO 6722, which its original version was established around 2000, came out with ISO 6722-1 in about 2008, which is the primary global standard for many years. But it did not cover shielded cables or multi-core cables. The highest rating was 600 volts, so it did not have 1,000 volt or aluminum conductors. Those requirements were covered in other ISO specification standards or in OEM standards. The newest one, the ISO 19642, has 10 parts, and it's the latest generation standard for vehicle cables and encompasses a broader array of cable types. Now, this just came out in 2019. The 10 subsections include things like definitions, test methods. The -3 is for 60 volt cables made of copper. -4 is aluminum, 60 volt cables. But what we want to talk about here is the -5, which is the single core high voltage for copper cables up to 1,000 volts AC and 1,500 volts DC. The 19642-9 is for screened and multi-core high voltage copper cables up to the same voltages I just mentioned. Now, what are some major takeaways or important things to note for the ISO 19642-5 and -9? They added new test procedures and performance values to address the evolving high voltage market needs. The one I mentioned before that helps with the connector and cable interface is diameter retention under pressure, and that's to improve the connector sealing. I should add in here that they also have tolerances for both the leads and the jacketed cables, which are also very important for the connector sealing. Cable flexibility. Cable flexibility has always been an arbitrary measure, and the ISO committee came up with some tests that quantify, using numbers, the relative flexibility of a cable. This helps in comparing one company's cable to another or a different type of insulation to another with regards to flexibility. Screening effectiveness. This helps to quantify and define shielding performance and also define the frequencies at which the tests are done. Ultimately, what we're trying to do here is to keep the noise that could be generated by the high voltage cables, keeping it from harming other components in the vehicle. Abrasion testing. This is a required test for 6mm and smaller. High voltage. The high voltage was increased from 600 volts AC to 1000 volts AC, and we added both 900 volts DC and 1500 volts DC to the specification. Shielded diameter tolerances. This was a very important thing that helps us standardize our cables. In the past, we used to call it the Wild Wild West with the cables and the connectors, all having different various sizes, even for the same size copper cable. You could have a 50mm that had ranges of diameters on the outside by a huge amount, making it very inconsistent, whereby single cable companies paired with single connector companies, and no one could use other people's cables with other people's connectors. And now, what the ISO committee did was they came up with standards for the jacket diameters with very tight tolerances. And that helps to improve the consistency among suppliers and connectors to give interoperability and lower cost. Major takeaway is the ISO 19642 is the latest vehicle standard and is more robust than the prior standards. Everybody, thank you very much.
Hi, this is Matt Hornick, and I am the EV and Hybrid Marketing Manager here at IEWC. First of all, I just would like to thank Charge Magazine for allowing IEWC and Champlain to give this joint presentation. And of course, I would like to thank Champlain for being our partner, our premier wire and cable partner for this space. So I would like to talk a little bit about our company. We are an electronics distributor. We specialize in both wiring cable and wire managed products. So wire managed products meaning things that would go to protect the wiring cable or might be a peripheral for it, like lugs, wire ties, etc. So we expanded into this market space about 10 years ago. We've been involved in automotive. It's really our sweet spot for about 58 years now. That's where we got our start. So we support the manufacturers, the OEMs themselves, all the way through the supply chain, and tier ones, tier twos, tier threes, a lot of startups, contract manufacturers, and we also support the SAE University competition team in this space as well. And we're very proud to do that. So we really here as a distributor, we're in the middle of our suppliers and our customers as well. And the idea is that we leverage that volume from all of these different suppliers. We consolidate them on a local basis to shorten lead times. We add value-added services, which I'll talk a little bit more about. But we do a lot of cut to length. We do a lot of printing. We do a lot of striping. We even do some cut and stripping of leads in some cases. We have product and application expertise. We have a lot of employees who've been with us for a long time and have been involved in these marketplaces that we service, whether it be automotive, aerospace, industrial. So we have those engineering solutions as well. And as I mentioned, we do support a lot of prototyping. In this space specifically, since there are so many startups, we do a lot of initiatives in that space as well. Really the one-stop shop for our customers. We try to help accelerate and simplify the way that you do business. That's our value. So we have a lot of strong long-term supplier partnerships, and in many cases, we have exclusive partnerships with leading automotive wire and cable manufacturers. Champlain being one of those. We support them with all of their high voltage products for this specific space. We have a comprehensive array of supply and logistics solutions as well, really geared towards the automotive market and therefore to EV and hybrid markets as well. Part of that, of course, as I mentioned, is supporting the prototypes and startups that are in this industry. So a lot of smaller volumes, or in some cases, just a few feet in order to help provide the start. So we stock a lot of material, specifically the Champlain products that we stock and have readily available, shielded and unshielded versions of the high voltage product, single and multi-conductor cables. We stock up to 120 millimeters squared. We also do a lot of single and multi-conductor standard automotive wires. We meet SAE requirements, ISO, JSO, 0.13 millimeters squared, all the way up to 120 millimeters squared, and the AWG equivalents. All of those we have in stock around all of our facilities throughout the world. So this slide's really designed to show you that we support this market and this space all the way from the product side, I'm sorry, all the way from the power generation side, all the way through to the actual interior of the vehicle itself. So the grid to charging in particular, a lot of THHN building wire, data cables. We do duct that goes into some of the power generation facilities, service entry wire. And then the charging stations themselves. So some of the OEM automotive manufacturers that are involved in the charging stations themselves, we support them. The contract manufacturers and the individual companies that produce or make these charging stations, we do a lot of work with them as well. Could be UL switchboard wiring, could be terminals, strain relief, switch boxes, etc. There's a lot of use of our products in those as well. And then the charging station to the vehicle, so the actual plug, the receptacle that goes from the side of the house, if you will, or from the charging station into the actual vehicle itself. Power tray rated cable, a lot of connectors and receptacles, cord grips, etc. there. And then interior to the vehicle, as we mentioned, of course, Champlain being one of the providers for us for that, for the high voltage battery cable and the primary wire I talked about. We do a lot of standard battery cable, a lot of lugs. We do a lot of automotive and commercial Ethernet cable as well. Champlain Cable being actually our premier supplier of that product as well. And as I mentioned before, ISO wiring cable, a lot of CAN bus offering as well. But really the idea here is that we support this entire market all the way through the supply chain. These are some of our EV supplier partners, in particular, Champlain being our premier on the wire and cable side. We do also offer on the wire management product side. We have some premier suppliers as well. TechFlex, Delfingen, Sumitomo, HellermannTyton are some other good examples, and you can find all of the entire list on our website as well. So a little bit by the numbers, just the size that we are IWC as a company. So we sell over 2.4 billion feet of wire and cable annually. We have over 63,000 part numbers online, more than 1,300 daily transaction. We have 10,000 plus customers located throughout the world. We have thousands of suppliers that support us and our customers. We have almost 450 employees now, and as I mentioned, we've been in business for almost 60 years. This map gives you a good idea, I think, where we're located throughout the world. Rather, 26 locations in 9 countries, serving customers in actually 96 countries. And you can see in North America, the big circle is our corporate headquarters and large distribution center. That's located outside of Milwaukee, Wisconsin, in a city called New Berlin. We have distribution centers on the East Coast. We have them on the West Coast and in Canada, and we also have them located in the Southwest and in Mexico to support all of our customers in North America. We also have locations in Europe and in Asia as well. So really just giving a snapshot that we can support our customers on an international basis. And we do have many customers who have 20, 30 locations located throughout the world that we actually stock locally for them in each one of those locations. So our value through expertise. I talked about wire and I talked about the wire managed products, but a little bit more about what we can offer. So on the quality side, ISO 9001, 2015, AS 9100 for the aerospace market. Services, as I mentioned, we do a lot of these in all of our facilities, from twisting to striping to respool. We offer engineered solutions as well. So with the expertise that we have, we are able to go in and do some designs for our customers, and we're where necessary, we bring in our suppliers. So for instance, we would bring Champlain in to customers that are looking for something very specific, maybe a custom design cable that they would be able to help us design as well. And then on the logistics and inventory management side, we have some interesting solutions to help save money and time, including the actual VMI with our cars program that we have. And there's more information available online for that as well. So how to work with us? Certainly visit our website. We encourage it. iewc.com /electric vehicle will actually bring you right to the site, a portion of our site rather, that supports this industry. Everything from wiring cable to wire managed products to our cars program, etc. But you can actually search by manufacturer. You can search by part, by description. We have live chat features, and we have a large e-commerce platform as well. In addition to that, we have a number of salespeople that are located throughout the world that specifically service this market. And you can get in touch with them through the website, or you can reach out to myself, and I will be happy to get you in touch with the correct person, depending on where you're actually located geographically. But the point here is that we have a large team that is able to help support this and understands this market well. So again, I just want to thank Champlain and Charged for allowing us to do this joint presentation. And I know we're going to move into the question and answer session. So hopefully these presentations have elicited some questions. Anything you'd like to ask, we would really be happy to answer. Appreciate your time on this, and I think we are ready to move to that portion. So thank you very much for your time.